In Math 8, students learn to solve systems of equations. They studied various ways of doing that, such as graphing, substitution, elimination. This year, we're going to concentrate on why elimination works. Let's say we had the system 2x plus y equals 13, and 4x minus 3y equals 11. In 8th grade, the students were taught to solve by elimination by taking one of the equations, multiplying through by a number. Sometimes it's just positive and negative 1. Sometimes we have to multiply through by a factor to eliminate a variable. On this particular equation, we would multiply the top one through by negative 2. We're going to take this top equation and multiply through by negative 2 to eliminate a variable. So here we get negative 4x minus 2y equals negative 26. And now we would look at this system. We would see that the x's will cancel and we add the two equations. And then solve, so we get y is 3. Sub back in and find our x. Now, when we taught them how to do it, we didn't necessarily explain why it worked. So let's take a look at each of these steps, one at a time. So we're going to look at the system once again and talk through each step. The system was 2x plus y equals 13 and 4x minus 3y equals 11. What I chose to do earlier was take the first equation and multiply the equation through by negative 2. The reason this is a valid step is because I'm using the multiplication property of equality. If I take an equation and multiply each side by the same constant, I still have two equal quantities. It remains equal. Now, when I change this, when I multiply through, and it becomes negative 4x minus 2y equals negative 26, why can I now add these two equations? The reason I can add these two equations is if we look at this, when we think about what an equation means, the left side of this equation must have the same value as the right side of the equation. Negative 4x minus 2y does equal 26. So basically, I am adding the same value to both sides. You can think about it as adding 26 to both sides. This is the addition property of equality. And we can even look at it a different way. We can think of it this way. If we take that 4x minus 3y and equals 11, we could look at it this way. We could say we're adding a negative 4x minus 2y to this side, and we're adding the 26 to this side. But because those are equal in value, I am just adding the same value to both sides of the equation. Therefore, it remains a balanced equation because I added equal amounts to both sides. When I do this, the x's will cancel, and I'm left with negative 5y equals, oh, this was a negative 26. A negative 26 equals negative 15. And y equals 3. But what we're trying to stress this year is the reason this works is when I multiply through on both sides so that I can eliminate, I am using the multiplication property of equality. And then when I add the two systems, I am really using the addition property of equality.